Hello children, outline of Haber's process we have already completed, and in this lecture we will discuss Haber's process in detail. Okay, so the first heading is reactants. In the production of ammonia, Haber's process, the reactants nitrogen and hydrogen in the ratio 1:3 by volume are first passed into the catalytic chamber. The first point, the reactant nitrogen gas is obtained by fractional distillation. So the nitrogen which we are using here in Haber's process is obtained by fractional distillation of liquid air. The reactant hydrogen is obtained from water gas, Bosch process. Okay students, so hydrogen is obtained from water gas and nitrogen is obtained from by fractional distillation of liquid air. A higher ratio of hydrogen or an increase in concentration of the reactants favors the forward reaction to give optimum yield of ammonia. So you also know that if the amount of reactant in any of the reaction will be more, it means more amount of product will form. Okay, so the amount of product is proportional to amount of reactant taken in that particular chemical chain. Here also, if you want to increase the amount of ammonia gas, so you have to increase the ratio of hydrogen, or you can say that concentration of the reactants. So you will get more amount of ammonia. The last point of this page, the reactants should be free from impurities. This is very important point, pure and dry. Why? Because impurities tend to poison the catalyst and reduce its effectiveness. So the gaseous mixture which we are using in Haber's process should be free from impurities, all type of impurities. Why? Because these impurities will poison to the catalyst, and that is why the activity of catalyst will decrease and the catalyst will not effectively enhance the rate of the reaction. Okay, so come to next page. The heading is temperature. Heading is temperature. An optimum temperature of 450 to 500 degrees Celsius is used in the Haber's process. So this is the optimum temperature. First point, if a reaction is exothermic, it is favored by lowering the temperature. And this is according to Leach-Atelier's principle. Okay students, so Leach-Atelier's principle you will study in detail in your higher classes. Okay, so with the help of Leach-Atelier's principle, we discuss the favorable condition for a chemical reaction or for a synthesis reaction. Okay, so with the help of this rule or principle, we can find out for a given reaction that which type of change in condition will favor for the higher yield of the product in that particular chemical chain. However, if the temperature is low, the speed of the reaction is slow and the yield of ammonia is low. Okay students, so if the temperature is low, then what will happen? The rate or speed of the reaction will also low and yield of ammonia will also low. Hence, an optimum temperature of 450 to 500 degrees Celsius is used in the above process. Above this temperature, the ammonia may decompose to give nitrogen and hydrogen. So we have to maintain this temperature. Okay, if the temperature will be low than this temperature, then you will get less amount of ammonia, and if temperature is higher from this temperature, then ammonia can be decomposed in nitrogen and hydrogen. So we have to maintain this temperature. Okay students, external heating is therefore not required. External heating is not required. Why? Because after the reactants are initially heated, since the reaction is exothermic, the evolved heat further maintains the temperature. So the reaction is exothermic in nature, and that is why we require only heating at the starting of the reaction. After that, reactants automatically will react because the reaction is exothermic in nature. So we have not required to provide temperature continuously in Haber's process. Okay students, the next condition is pressure. An optimum pressure of 200 to 900 atmospheres is used during the process. If a reaction proceeds with decrease in volume, as here 1 volume of nitrogen and 3 volume of hydrogen are forming 2 volumes of ammonia, then the forward reaction is favored by increasing the pressure. And this is statement according to Le Chatelier's principle. Okay students, so if any chemical change is taking place in such a way that volumes of reactant are greater than volumes of product, then to get more amount of product, you have to increase the pressure of that chemical change. But in this case, however, if the pressure is too high, the production plant may not withstand the pressure. Okay, so for the formation of ammonia, higher pressure condition is favorable according to Le Chatelier's principle. But if pressure is too high, then what will happen? The production plant may not withstand the pressure. Hence, an optimum pressure of 200 to 900 atmosphere is used. So, we are not going to increase the pressure from 200 to 900 atmosphere. Okay students, so before moving further, I would like to explain you Le Chatelier's principle in a very short manner. Okay students, so as I told you that Le Chatelier has given some rules, some points on the basis of which we can discuss favorable conditions to obtain more amount of product in a particular chemical change. Now for example, in the case of ammonia formation, you know that in Haber's process 3 volumes of hydrogen and 1 volumes of nitrogen are reacting and forming 2 volumes of ammonia, and the reaction is exothermic in nature. Okay students, so according to Le Chatelier's principle, we can change in external conditions of the reaction. So by putting some change in external conditions of the reaction, we can have comparatively greater amount of the product. Okay, so these conditions in which we can change are, first is we can change in the concentration of reactant. Okay, second we can change in temperature, and the third we can change in pressure. So first we will discuss change in concentration of reactant. So as I already told you that if we are going to increase the amount of reactant, always you will get more amount of product. Okay students, so amount of reactant is always proportional to amount of product. So if you are increasing amount of reactant, you will get more amount of product. Same here also. if you are increasing amount of hydrogen, nitrogen, it means you are going to get more amount of ammonia. Okay, so we can change in concentration of reactant. And which type of change we are going to do? We are going to add more amount of reactant, then we will get more amount of product. And same way, if we are going to decrease the amount of reactant, then amount of product will also decrease. Then second condition is change in temperature. So this change in temperature is depend upon the type of reaction. Which type of reaction? On the basis of change in heat. So as you can see here that plus delta sign is there, it means ammonia formation reaction is a exothermic reaction. So according to Le-Chatelier's principle, for exothermic reaction, decrease in temperature will be favorable condition to get more amount of product. Okay, and for endothermic reaction, increase in temperature will be favorable condition to get more amount of product. So here this reaction is exothermic in nature, so it means we have to decrease the temperature to get more amount of product. Okay students, and the third change is change in pressure. So change in pressure, for change in pressure we are having three different conditions. Now if for a given reaction number of moles or number of volumes of reactant are less and number of volumes or moles of product are more, then what we will do? We will decrease the pressure. Okay students, if number of moles or volumes of reactant are less and product are more, then we will decrease the pressure. But if the reverse condition is present, number of moles or volume of reactant are more and product are less, then we will increase the pressure as the condition in this reaction. Okay, so here you are having 3 volumes of hydrogen, 1 volume of nitrogen, and you are forming 2 volumes of ammonia. So overall decrease in volume. It means for this particular reaction to get more amount of ammonia, according to Le-Chatelier's principle, you will increase the pressure. Okay students, and the last condition is the number of moles of reactant are equals to number of moles of product, then there will be no effect of pressure. Okay, so if both the sides number of moles or volumes are same in the reaction, then there will be no any effect of pressure. So there is no any need to change the pressure also. Okay students, so in short I am going to repeat again these all points. We can discuss favorable condition for any chemical change under 3 different headings. And these headings are concentration of reactant, change in concentration of reactant, change in temperature, and change in pressure. So first, as I told you that if amount of reactant in any reaction will be increased, product amount will also increase. So this is a universal point. If reactant will increase, product will also increase. The second point, change in temperature. If the reaction, given reaction is exothermic in nature, then you will decrease in temperature. So decrease in temperature will be favorable condition for that reaction. And if reaction is endothermic, then favorable condition will be increase in temperature. The last point, change in pressure. Change in pressure, if number of moles of reactant or number of volumes of reactant are less and product are more, then you will decrease the pressure. If number of moles or volumes of reactant are more and product are less, you will increase the pressure. And if number of moles of reactant and products are equal, then there will be no any effect of change in pressure. Okay students, so to discuss this Le-Chatelier principle, we can take one more example. We can take one more example, and this example belongs to formation of nitric oxide. Formation of nitric oxide. So in the formation of nitric oxide, we use N2 plus O2, which form 2NO, and let the reaction is endothermic in nature. Let reaction is endothermic in nature. Then for this reaction, according to Le-Chatelier, if we want to get more amount of NO, nitric oxide, then which type of changes we will do here in different external conditions? So first, change in concentration of reactant. So what we will do to get more amount of nitric oxide? We will increase the amount or concentration of reactant. Okay, students. Then second, change in temperature. So the given reaction is endothermic in nature. So what will be the favorable condition for temperature? We should increase the temperature. Okay. So change in temperature, increase in temperature. And the third point, change in pressure. So because in this reaction, number of volumes or number of moles of the reactant equals to volumes or number of moles of product. So there will be no any effect of change in pressure. So there will be no any change in pressure. Okay, students. So these the favorable condition for formation of nitric oxide with the help of nitrogen and oxygen, that we have to increase the amount of reactant. Second, the temperature should also increase because reaction is endothermic in nature. And pressure, there is no need to change in pressure because number of moles of reactant and products are same. Okay, students. So we are moving towards the next heading, catalyst. A catalyst is required to accelerate the reaction at optimum temperature. So the catalyst used is finely divided iron. It is mixed with small amounts of the promoter, molybdenum. And what is the symbol of molybdenum? MO, which enhances the efficiency of the catalyst. So what is the function of molybdenum? Promoter. It enhances the activity of the catalyst, finely divided iron. Okay, so just then next point, the catalyst only accelerates the reaction and does not form a part of the reaction. Okay, so catalyst only enhance the rate of reaction, only it increase the rate of reaction, but it's not going to take part in chemical reaction. Okay, hence it does not affect the percentage yield of ammonia. Then last heading is the product ammonia. The ammonia is separated and recovered from the uncombined nitrogen and hydrogen by techniques based on the physical properties of ammonia. Now, which important physical properties ammonia is carrying? So first, this table is given. physical property of ammonia involved. So we can separate ammonia from nitrogen and hydrogen by liquefaction. Okay students, so why we can do this technique, we can use this technique for the separation of ammonia? Because ammonia is easily liquefiable. Why it is easily liquefiable? It condenses to a liquid at around minus 30 degrees Celsius at 8 atmosphere pressure. Okay, N2 and S2 are difficult to liquefy. They condense at temperature around minus 196 degrees Celsius and minus 253 degrees Celsius respectively, and at comparatively higher pressure. So liquefaction of hydrogen and nitrogen is comparatively very hard, but of ammonia is comparatively very easy. So that is why from the mixture of ammonia, hydrogen and nitrogen, only ammonia is liquefied and get collected in the reservoir, whereas hydrogen and nitrogen remains in its gaseous form. Then second technique we can use, dissolving in water. Ammonia is highly soluble in water. 1 volume of water dissolves about 702 volumes of ammonia at 20 degrees Celsius and 1 atmosphere pressure. So you all know that ammonia is a basic gas and it is highly soluble in water. So its aqueous solution will be alkaline in nature. So students, can you give me one example of a such gas which is acidic in nature and highly soluble in water? Okay, so that gas is HCl, and it is also highly soluble in water like ammonia. And aqueous solution of HCl is acidic in nature. So aqueous solution of ammonia is alkaline or basic in nature, whereas aqueous solution of HCl is acidic in nature. So N2 and H2 are almost insoluble in water. So this is the difference between the solubility of ammonia and nitrogen and hydrogen in water. So on this property basis, on the basis of this property, we can separate out ammonia from hydrogen and nitrogen gases. Hence, liquefaction and dissolution in water are two techniques used for separating ammonia from the uncombined nitrogen and hydrogen reactant mixture during Haber's process. Okay students, so this much for today in this lecture. From next lecture we will discuss fountain experiment related to dissolution of ammonia in water. Thank you.